Hey, it's Evan Reese, the OnSherpa. I saw this question on the OnShape forum today about how to get the radius of a cylinder. And I thought that this would be a good kind of bite-sized little FeatureScript example that I could do and maybe also help somebody out in the process. So this is not really a complete FeatureScript tutorial, but I am going to kind of talk as if you are not that used to FeatureScript. So I'll be stream of consciousness, reviewing what I am thinking about and all of that. So hopefully you can pick up more than just how to get the radius. I know for me, learning FeatureScript, it took a certain amount of just like repetitions and just consuming any information that I could about it until it started to click. So hopefully, if you're interested in FeatureScript, I wouldn't worry too hard about trying to learn this specific thing or that specific thing. Just like continue to expose yourself to it and solve small problems, and eventually you'll get the hang of it. So all right, let's get after it. The first thing we need is a Feature Studio. Do that here. And I'm going to hit New Feature, and we'll call this one Cylinder Face, I guess. And internal name will be Cylinder Face. So in FeatureScript, this is the user-facing name. That's the name of the feature. And this is the internal name. We're actually creating a function that could be called in another feature. So if I were to use this feature, or even like the extrude feature, that function is called extrude. So that's what I'm calling it. It doesn't really matter too much in this scenario because I'm not doing anything with this later, but it's just good practice to name that stuff. So the anatomy of this here, we have two curly brace sets, and this precondition is here, and it tells you what we're doing. Define the parameters of the feature type. This means this is the user interface. This is the stuff that pops up in the window that you can add when you're selecting items or you're typing in numbers or whatever. That's all this stuff here. And then down here is the function's action. This is what the feature does with the information the user gives it. So let's make the simplest user interface ever. There are snippets up here, and I'm looking for a query parameter. I can also just what I do is start to just type query and hit enter. We'll call that face. And it highlights these different things inside of here, and I can just tab through them with the tab key or shift tab to go back. So it's you don't have to leave the keyboard to get these things filled out. So it has a filter by default, and it's going to filter it to faces. I could filter for bodies or something like that, and I can also add to this. So I'm going to do a double ampersand and add geometry type dot cylinder, and that will make sure that we can only click things that are cylindrical. So it would be like fillet edges or holes, things like that. And I'm only going to do one face at a time, so I'm going to leave max number of picks at 1. If I didn't want to limit how many things the user could pick, I could just close that out completely instead, and that would work just fine. The nice thing with having it set to 1, if we really do mean just 1, is that when you have that field highlighted in the user interface, when you're using it, if there's already something in there and you click something else, it replaces it instead of adding it and then having to do some other stuff to figure out what's. So we just need to name the internal thing. This is what we'll call down in the feature later when we want to get that face. So I'm going to call it something easy to remember, definition.face. That's cool. All right. So our goal here is to get the length and the diameter of this cylinder. So we've already limited to only cylindrical type of things. And I'm going to make some assumptions here. There's some edge cases we'll talk about, but I'm going to assume that the user's only going to be right now I'm only going to handle things that are true cylinders. This is also a cylindrical face, but it's not a complete cylinder. And I'm not handling that case right now. I'm just going to handle basic cylinders. Okay. So to define the action, first I'm going to get an axis for this cylinder. So I happen to know that there's a function for that. I'm going to just do const axis equals EV axis. This is, anytime you see EV, it's an evaluation function. So it's looking at some existing geometry and analyzing it in some way. So if you mouse over that function, it tells you what it's looking for. Arg is a map, and that is this map. And that map has a couple of arguments inside of it, like has parameters. The only parameter in this one is axis. So there we go. And if you mouse over it, we can look. Axis is a query. We're looking for a query, and that is what this query parameter is going to give us. So I'm going to type definition.face here. And when it's a little tiny thing like that, I don't feel like it has to be on multiple lines like that, so I'll often just do this. Okay, now mousing over this function again, you can see what also, I just looked at it to show you what goes into the function, but you can also see what comes out. And it says it returns line. And when you see it with a capital letter like that, it's letting us know that it's not just a line like you would use in conversation, it is a line as in a type. And we can click this and it'll take us to the documentation and show us what line means. In this case, a line is a map, and that map contains two key value pairings. It has an origin, which is going to be a vector, and it has a direction, which is also a vector. So we're getting a map with origin and direction. Now, I want to get a coordinate system for something I'm going to do later. And so how can we get a coordinate system from an origin and a direction? Let's try. I'm going to make a constant called CSys, and we'll start typing chord system and see what our options are. We have two options here. We have this one that needs an origin, an x-axis, and a z-axis. We don't have an x-axis, and I don't want to bother trying to make one right now. I suppose that I could probably do a perpendicular. I think there is a perpendicular vector. Yeah, so I could do that and create one that way. But there's a slightly even easier way. There's this other coordinate system that takes a plane and just converts it to a coordinate system. And if I begin to type plane, we have a little bit more in terms of functions. And we have one that only needs an origin and normal. So that's the same things that we have here inside of our axis. So the origin is going to be axis dot origin. And the reason I know that it is that, just reminding you here, is because those are what is inside of our line. Origin and direction. I'll copy that. And this will be axis dot direction. Okay, let's look at our coordinate system and make sure that it's working. I'm going to use debug, tab over, CSys, I'm just starting to type it, and then I'm going to hit enter. Command S to save, same as clicking the commit button. It's not really saving, it's just committing the code so it runs. And we'll come back into our Part Studio and check it out. Okay, oh, by the way, I've got this thing off at a weird angle like this because I didn't want the feature to accidentally work because it was aligned with the world coordinate system. So this will help me make sure that the axis is oriented correctly because it is done correctly, not because it happens to also align with Z or something. So, all right, cylinder face. You can see that filter working for us. It doesn't pick anything except for cylindrical faces. Let's grab that one. And there we go. We've got our coordinate system showing up. Let's try this one. And if I were to suppress one of these, does it align with that? Yes, it's going to follow the alignment. So that's great. That's what we want. Okay. Now, let me show you what a coordinate system is, just so you know. I actually don't need to know this for this feature, but coordinate system, here we go, a type, it's a map. It has an origin, x-axis, and z-axis. So pretty straightforward. Very similar to the axis. It just has an x-axis as well. And the names are different. You gotta kind of remember that. With a plane, it's origin, normal, origin, x, and normal or something. It's like very similar, but instead of normal, we have z-axis. So you just gotta come and check if you forget what the keys are for the certain map you're working. Okay, there's our debug. The next thing that we are going to do is use a function that creates a bounding box around our object. It can do it around any geometry, and ours is a cylinder. So let's do that. I'm going to do another constant. I'll call it bbox, and I'm going to use evbox3d. Again, ev indicates an evaluation, meaning it's going to look at some of our geometry and do something with it. All right, let's look at our two keys here. Topology. If I mouse over this, it'll tell us about it. The entity to find the bounding box of, that's going to be the face. Definition.face. And then let's mouse over this again. Tight, get the tightest possible bounding box, defaults to true, and false for a box that's at least as big as the given entities using a faster algorithm. So in our case, we want true because we do want it to be tight because we're using this to get actual measurements. You might want it not to be tight, if you want a feature that is a little bit faster and all you need to know is the minimum size of a thing, because this will never be, it'll never make a box that's too small. It'll always err on the big side. So for example, the extrude feature has a through all option. How does it know how far is through all? It doesn't go infinite. That's not possible, actually. There is a maximum size in Onshape. It's just huge. But it actually probably is doing a bounding box around everything that the feature might interact with, and then taking the diagonal length of that box, knowing that that will be bigger than anything in the Part Studio. So that's one function or one use case for a loose bounding box. But we're going to do a tight one. And then if I mouse over this again, you can see there's this third one that didn't auto-populate. And you'll run into this when you pull out certain functions. A lot of them have like 10 different things you can put in, and you don't need all of them all the time. But I do want this one. It's a coordinate system that will let us orient our bounding box to the cylinder itself. In fact, I'll show you both ways, but just to add this in there, you got to remember that this argument is a map, and a map is denoted by these curly braces, and then it's a set of key value pairings. So topology, and then we give it the value. And tight is the key, we give it true. And they're all separated by a comma, except the last one. I have found that it doesn't cry at me if I do add this extra comma and leave it even as the last one. So that can be a kind of nice if you just want to be sure that when you want to add something else, you just come in, add it. And then because this is already that same name, I can put that there. This could also be called something like that. And as long as these are the same, we're good. I'm just going to. But yeah, I can add that last comma or not. It doesn't really matter. This one I'll leave out. I could do it single line like that, but it has multiple inputs, so it's a little more readable to me like this. Let's debug that box. One thing that is interesting about bounding box, and maybe a little confusing at first, is that it's going to always put it on the world coordinate system. We gave it a coordinate system for the cylinder, but it's actually going to kind of transpose that down to the world coordinate system. And that does make these a little bit easier to work with in some ways that I'll show you in just a sec. And real quick, I want to show you what happens if we don't give this a coordinate system. If I just comment that out, you can see that we didn't give it a coordinate system, and it's putting a box oriented to the world axis here. So that's not what we want. We want the box to always align with that. Here we go. All right, and let's take a look once again at this argument, or at this function, and see what it gives us back. It says it returns box 3D. This is another type. Let's click it. Go check the documentation for what's inside. Inside of box 3D, it's another map. And it has a key and value pairing of two vectors, the minimum corner and the maximum corner. Let's debug those. Not box 3D, B box. Yep, that's my variable that I declared, or constant. And the two arguments were, or the two keys, min corner, and I'll do max corner, and we'll make that green just to show you the difference. Let's go back and look at what we have. Okay, so you remember the box that it was giving us. This, well, I'll do the box as well in yellow. Let's look. Cool. So here's what's inside. The lines of the box are really just implied. The only actual data inside is two vectors. We have the min corner and the max corner. That's all that the box contains, which is great. It's a very lightweight amount of data. So you can do these and pass them around. All the lines are implied because of the coordinate system of the world that we're in, or the coordinate system that we fed that. And in our case, it should be square because we're dealing with cylinders and all of that. So that's what we're working with. We have two vectors. So how from these two vectors can we figure out the diameter of the cylinder and the length of this cylinder? Well, the length is just going to be the difference in z height between these vectors. And the diameter is just going to be the difference in either the x length or the y length. And we can choose. It doesn't really matter which. So let's go figure out how to get that information. First, I want to remind you what a vector is. A vector is really just an array So it's got braces like this, like that. And it can be unitless, or it can have units. So if it can have inch, something like that. So in order to get the contents of an array, you may recall we need an index here. So let me actually just say that this vector is going to be 5, and this will be 0.5. This is more like our cylinder. So if I put a 0 in, it'll give me that. If I put a 1 in, it'll give me this. And if I put a 2 in, it'll give me that. So that's how we get it. And another note on vectors, they can have units or not have units. You can do it like this. I can do 0.5, 0.5, 10 times inch. I can do that. Or I can multiply each value inside by a length unit. And I can mix and match. I usually use inch just because it's shorter to type. But what I can't do is have a number here and length units here. That will fail. So it either needs to be multiplied, 3 straight up numbers with no lengths on the inside, multiplied by a unit, or they all need to have units on the inside. And let me just we'll get to that in a second. I'll do a more clear demonstration. But the key right now is to know that a vector is an array of 3 values. So to get the difference in the z height, which is our length, I just need bbox dot min corner 2. That's our the z value of that vector minus bbox dot max corner. And I guess really I can reverse this. I suppose the max corner will always be on top. Or if I wanted to be even more certain, I could wrap all of this in an absolute function like this. I think it doesn't need this, but if I had done the min corner first, then it would be a negative number, and it really doesn't matter to me. It just should be absolute. So I could wrap it anyway. It doesn't really matter. So that's the z height, or the length of our cylinder. And to get the diameter, it's just going to be either x or y. So it doesn't matter if it's a 1 or a 0, as long as it's the same for both. All right. And now just to confirm that we've got it right, I'm going to use f cylinder, and this will create a cylinder in space. So it needs a center location, a top center, bottom center, and a radius. And I don't know why top is at the origin and bottom is up in space, but it doesn't really matter which end is which. So here's a better example of what I was talking about. This is a vector that has unitless numbers inside and is multiplied by inch. And that's fine. That's the origin. That works. It's just, that's where we want it. But for this one, we want this to be 0, 0, and length. And that's not going to work because 0 as a number, and then length, this one already has units. So it's going to cry at us. I'm going to get rid of that. And instead, I'm going to multiply these by inch inside of here. Radius will be diameter divided by 2. All right, and we've made a cylinder that matches the cylinder that we picked. I can also click that, and it will do that one. I can get rid of these debugs now. I don't need them. Command S to commit. Come back over here. So now we are creating a copy-ish, a cylinder of the same size as the one that we select. If I were to modify these, let's say I move face, I'm going to move this face, I'm going to rotate it, realign. Sure, let's rotate it about that. I'm just trying to get it so it's not straight. Let's see what we get when we check that one instead. It should give us the total longest possible length and ignore the fact that it's short. So let's confirm that. The distance from here to here, max distance, that's not really very useful. I'm going to unmove all that. There we go. Just do it this way. Pierce. Coincident. Cool. 27.251. And yeah, so that's the length. That is correct. So it just gave us the longest length of the cylinder, assuming that the edges are not, cut perpendicular across. One other thing I just wanted to point out, since I am trying to make it a little bit more beginner friendly, I just want to show you how to troubleshoot, how to read an error. So let's pretend that I had a typo here in the coordinate system. And I'm going to come over here and our feature is going to fail. And it'll just say error regenerating. And you're like, what? So you can come up here to the FeatureScript notices, click that, and it'll start to tell us a little bit. We're in Part Studio 1. If I had other tabs, those would show up here. But we're looking here, and this is the error, the runtime warning. So it is saying call plain undefined, comma, vector array does not match plain vector and ... Let me break that down. So this is saying this is what I called, and this is what it wants, and this is how they don't match. And the ... is like, you got that part right. That part matches. Cool. But this part, we need a vector. You gave us undefined. So that would then be my clue to be like, okay, I know that shouldn't be undefined because I made an axis and I put in the origin. So then I would come back and see that I had a typo. So that is how I would read these error messages. Okay, I know that's not comprehensive, but hopefully it's just going to help you slowly whittle away at FeatureScript, and that you've picked up more than just how to measure a cylinder in FeatureScript. I think in a lot of ways, it just does take time and exposure and practice and kind of stubbornness and all that good stuff and curiosity. So stick with it if you're new to FeatureScript, and you'll pick it up before you know it. Subscribe for more stuff like this. It'll help boost my channel. Hit like and all of that if you got anything out of this. It just helps boost the channel so that I can produce more content like this. Thanks so much for watching. I appreciate it, and I will see you in the next one.